The first 30mm round exits the GAU-8 Avenger at roughly 3,300 feet per second. In the space of a single heartbeat, 64 more follow behind it. The force of that burst sends a brutal wave of energy through the aircraft, shaking the frame and briefly bleeding off a bit of its forward speed. 4,000 feet below, the sea explodes upward. The rounds cut through their target. When high-speed depleted uranium penetrators hit the fiberglass hull of an IRGC fast attack boat, the reaction is almost immediate. Systems inside the craft fail in a chain reaction as pressure and heat tear through fuel lines, cooling channels, and internal machinery. A boat that had been racing across the water at 45 miles per hour vanishes from the surface in an instant. That moment becomes the opening move in a new tactical pattern, one that shattered nearly every assumption the Iranian Revolutionary Guard Corps had made about where the US Navy's limits began and ended. The Strait of Hormuz is a 21-mile-wide bottleneck where the usual rules of naval combat start to break down. In those tight waters, even an Arleigh Burke-class destroyer, a $2.2 billion marvel of modern engineering, runs into a harsh numbers problem. Its AN/SPY-1D radar was built to spot supersonic threats near the edge of the atmosphere. But at sea level, it has to fight through a wall of interference. Wave tops, salt spray, and the constant movement of thousands of commercial ships crossing the Persian Gulf every day. That is exactly the weakness the IRGC's swarm doctrine was designed to exploit. By sending out 30, 40, or even 50 small fast attack boats at once, they force a saturation problem. For the commander of a US destroyer, the real challenge becomes one of logic and cost. Launching a RIM-162 ESSM means using a $1.1 million missile to stop a boat worth less than a used pickup. And the bigger issue is not just price. Every missile fired leaves one less layer in the ship's defensive reserve. Once those vertical launch cells are empty, the ship has to pull out of the fight and head to a specialized port to reload. We all know that one piece of equipment sitting in the back of the garage. Maybe it is a 1970s Ford F-150 or an old cast iron skillet handed down from your grandfather. It does not have a sleek profile, smart features, or digital displays. But when the newer, more advanced version quits because one sensor fails or one circuit gets wet, that old workhorse keeps going like nothing ever happened. That is exactly what the A-10 represents for the US military. It is the old, dependable workhorse the Pentagon tried to retire 5 different times, only to discover that when things get serious, the older method is sometimes the one that still delivers. If you have a tool at home that is older than you but still works every single time, share it in the comments. We want to hear about the everyday warthogs in your life. The arrival of the A-10 Thunderbolt II in the Persian Gulf changed the equation in the Strait of Hormuz through one key advantage: connected targeting. The A-10 is not operating by itself. High above the noise and surface clutter, a P-8 Poseidon Maritime Patrol aircraft serves as the coordinator of the fight. Using its APY-10 radar, the P-8 builds a high-resolution picture of the entire swarm. It can sort out which boats are armed with heavy machine guns and which ones are carrying rocket launchers. That targeting data is then sent straight into the A-10 cockpit through Link 16. From a tactical point of view, this completely changes the efficiency of the mission. The A-10 pilot does not need to waste time or fuel searching across the water. The tactical display is already populated with digital markers, each one tied to a specific IRGC boat. The A-10 drops from its transit altitude of 15,000 feet and descends into the engagement zone at around 350 miles per hour. Because the aircraft uses a straight-wing design, it stays highly maneuverable at lower speeds. That gives the pilot a major advantage when trying to keep eyes on several moving targets at once, especially in the cramped waters of the strait, where a much faster jet like the F-35C can have a harder time working comfortably. As the A-10 levels out at 3,000 feet, the pilot selects the first weapon in the sequence, the APKWS. This is where the logic of the whole system becomes clear. Instead of spending a missile worth around $1 million, the A-10 fires a 2.75-inch rocket fitted with a laser guidance kit. At roughly $22,000 per shot, the APKWS is one of the first weapons in this scenario that actually gives the US the edge in the cost-to-effect equation. The pilot locks the lead IRGC boat with the AAQ-28V4 Lightning targeting pod. One squeeze of the trigger sends the first rocket away. The motor ignites and 4 guidance fins unfold from the middle of the rocket. It begins tracking the reflected laser energy coming off the target. In the fast-moving conditions of the strait, the IRGC boats are weaving hard to throw off incoming fire. The APKWS guidance system adjusts for that movement. The rocket hits the engine section of the lead boat with accuracy measured at less than a meter. Its propulsion is knocked out, sending the craft off course or leaving it dead in the water. For the IRGC, that is the first moment when expectations start to fall apart. They believed precision would run out quickly. What they did not expect was the A-10 carrying 38 of these guided rockets in its pods. By the time the third boat is struck, the swarm's formation is already falling apart. Its biggest advantage, mass and momentum, disappears. The attackers are no longer moving as one. Now they are exposed, separated, and easy to track. With the swarm broken up, the A-10 pilot switches the master arm to the gun. The aircraft rolls into a 30-degree dive. On the head-up display, the CCIP reticle appears, a digital aiming circle showing exactly where the 30mm rounds are expected to land, factoring in wind, airspeed, and dive angle. The GAU-8 Avenger begins to spin. In just 0.2 seconds, the 7 barrels reach their full firing rate of 3,900 rounds per minute. What follows is a raw mechanical roar, a sound that can carry for miles over open water. A burst lasting just 0.7 seconds sends 45 rounds toward the second boat in the formation. Each one is a PGU 14/B armor-piercing incendiary round built around a sub-caliber depleted uranium penetrator. When these rounds hit the water, the impact sends a powerful pressure wave outward. Even near misses can generate enough force to stress and deform the thin fiberglass hull from the side. The rounds that connect pass through the boat with almost no resistance. A 30mm hit on a marine engine block is a brutal display of physics at work. Whether the engine is cast iron or aluminum, it cannot handle the energy of a round moving at roughly Mach 3 or around 2,300 miles per hour at sea level. The engine breaks apart into high-speed fragments, and those fragments tear through the rest of the boat from the inside. The A-10 pulls out of the dive, and the pilot feels 4 Gs as the aircraft levels off at 500 feet. But instead of turning away for a long recovery, the jet simply circles back. That is one of the A-10's greatest advantages: time over the target area. It remains overhead, engines rumbling, waiting for the next boat to make a move. There is a real irony in why the A-10 works so well in this environment. It was originally built in the 1970s to destroy Soviet tanks across the plains of Germany. It was designed to fly slowly enough for the pilot to keep visual track of targets, and it was built with exceptional toughness so it could survive hits from anti-aircraft fire. The IRGC swarm depends largely on small arms and shoulder-fired missiles for protection. Against a lightweight high-speed jet, that can be a serious threat. But the A-10 pilot sits inside a 1,200-pound titanium armored cockpit, often called a titanium bathtub, built to withstand direct hits from 23mm explosive shells. The aircraft was built with backup flight control systems and engines mounted high and far apart, reducing the chance that a single hit could disable both at once. From a military historian's perspective, the A-10 stands out as the one aircraft in the U.S. arsenal that feels completely at home in the kind of environment a swarm creates. It can operate under pressure from light defensive fire, shrug off machine gun threats that would seriously challenge more fragile aircraft, and put out a level of sustained fire that few other platforms can come close to matching. What makes that especially striking is that the A-10 answers a problem that even $2 billion Navy destroyers struggle to solve. And it does it with a 50-year-old airframe and a rocket that costs around $22,000. That is the lesson at the center of this story. The newest technology is not always the most useful. Sometimes the real advantage comes from using the tool that disrupts the enemy's thinking and breaks their sequence before it can work. As the engagement continues, the A-10's practical logic becomes even clearer. The aircraft carries 1,150 rounds of 30mm ammunition. Even after 5 strafing passes, the pilot has used only about a quarter of that supply. Compare that with the F/A-18E Super Hornet, which carries around 500 rounds of 20mm ammunition, a lighter caliber without the same penetrating effect as the A-10's 30mm rounds. The Super Hornet would need to head back to the carrier for rearming after only a short time in the fight. The A-10, by contrast, can remain over the strait for as long as 4 hours, taking fuel from a KC-135 Stratotanker if needed. That staying power is what ultimately breaks the swarm's confidence. They cannot simply wait for the A-10 to leave. They cannot disappear into the visual chaos of the water because the P-8 Poseidon is still high above at 30,000 feet, feeding updated targeting information to the A-10 in real time. One by one, the boats that remain begin trying to run back toward the Iranian coastline, but the A-10 holds the advantage in control of the situation. It does not just chase them, it funnels them, limits their options, and keeps pressure on every movement. In many cases, a short burst placed just ahead of a fleeing boat is enough to force it to stop or give up the escape attempt. This version shifts the focus away from simple action beats and turns the sequence into a tighter tactical analysis, showing how the swarm is finally suppressed step by step. The U.S. Air Force's decision to move the A-10 Thunderbolt II from a primarily land attack mission into maritime interdiction was a direct answer to the magazine depth problem facing the U.S. Navy. By putting the Warthog over the Strait of Hormuz, CENTCOM effectively transferred the burden of close, asymmetric defense away from the fleet's most expensive frontline ships. When a destroyer remains positioned in the outer defensive ring, its vertical launch system stays fully stocked with high-end interceptors such as the RIM-162ESSM and RIM-66 Standard Missile. That reserve ensures the carrier strike group is protected against advanced, high-speed anti-ship threats that truly demand that level of capability. In that structure, the A-10 functions as a kind of operational buffer. It absorbs the lower-tier engagement workload, allowing naval forces to preserve their most expensive interceptors for targets that justify the cost and complexity. The result is a more efficient allocation of firepower across the entire battle network. The presence of the A-10 Thunderbolt II reflects a shift toward a sustained, integrated kill chain, where the cost of engagement is finally brought below the cost of the target. That shift directly undermines the IRGC's deterrent strategy, which relied on the assumption that the U.S. Navy would hesitate to spend million-dollar weapons on inexpensive, fast-moving threats. Now, with detection handled by the P-8 Poseidon, coordination flowing through Link 16, and engagement executed with APKWS guided systems, the maritime battlespace becomes a continuously monitored, continuously managed environment. It allows the U.S. to maintain persistent pressure without rapidly draining strategic missile inventories. At its core, the situation in the Strait of Hormuz was never just about raw firepower. A carrier strike group already holds more kinetic capability than the combined Iranian military. The real competition was about sequencing, how quickly and efficiently threats could be detected, assigned, and neutralized. For years, naval doctrine leaned heavily on high-end systems to solve problems created by low-cost, asymmetric threats. In practice, that meant using billion-dollar platforms to counter relatively cheap, expendable craft. It was technically effective, but strategically inefficient over time. The A-10 fits into that gap because it was built for a different style of conflict entirely. One defined by persistence, repetition, and sustained pressure, rather than single decisive exchanges. By extending its role from land operations into maritime interdiction, the U.S. military demonstrated that adaptability can outweigh pure technological advancement. In that framework, the IRGC expected a naval force constrained by cost and hesitation. Instead, it encountered a networked system that values efficiency, persistence, and rapid response over prestige hardware. The real betrayal of expectation was the assumption that the United States would be forced to operate strictly within the constraints of modern, high-cost warfare. The A-10 disrupts that assumption entirely. It does not conform to the idea that every engagement must be expensive, complex, or dependent on cutting-edge systems. Instead, it breaks the pattern by prioritizing endurance, efficiency, and sustained presence. Looking ahead to future flashpoints like the South China Sea or the Red Sea, the broader lesson remains consistent. Sequence matters more than raw firepower. If a force can detect faster, strike at lower cost, and maintain presence longer than its opponent, it does not need the most expensive platforms in the fleet to dominate the fight. It only needs systems that can endure, adapt, and keep pressure on the target without pause. The swarm concept still exists. Fast, small boats are still fast, still numerous, still difficult to manage in cluttered environments. But the strategic landscape around them has shifted. The constant low-frequency presence of systems like the GAU-8 Avenger changes the psychological and tactical equation. It signals that the cost imbalance the swarm relied on is no longer guaranteed. In that sense, the challenge of small distributed threats was not solved by a single breakthrough weapon or a billion-dollar program. It was addressed through a return to a simpler idea: persistent platforms with deep magazines and the patience to stay in the fight. What emerged was not a product of a lab or a new procurement cycle, but a Cold War-era design still doing what it was originally built to do: survive, persist, and deliver overwhelming force when needed. Ultimately, the A-10 did more than relieve pressure on naval missile inventories. It reshaped the logic of engagement in confined maritime spaces, proving that efficiency can matter more than prestige and that older systems can still redefine modern problems. In the end, the Warthog's real legacy is not about nostalgia or legacy hardware. It is about a simple truth that remains relevant even in an era of stealth platforms and cyber operations. There is still a role for direct, visible, overwhelming kinetic force when the situation demands it.